This is my review of the Sportsman GEN2000 generator, which I recently purchased. It came in a box, actually a box within the box. This was the inner box, very well packed. The unit arrived in good condition, and I have to say the manufacturer did an excellent job of packaging it up. Okay, on opening the box, we had included with it some tools, which I have laid out here, which I didn't expect since it wasn't mentioned in the ad. But it included a funnel, spark plug wrench, a screwdriver. This is a double-ended flat blade Phillips screwdriver, and a set of cables that will plug into the DC output of the generator. And I understand that it can be used for charging a battery. Also included with the paperwork was the usual material and products, other products handled by this manufacturer, and a warranty send-in card and a description of the warranty. Also included was a manual for the generator and a quick startup card that tells you just how to get the unit up and running. I would like to mention here that the manual is, in my opinion, a keeper. It seems to have been written by someone very proficient in English, or perhaps a native speaker, and it includes diagrams and parts numbers and so forth that could be very helpful for you in the future when parts are needed for the unit. The control panel is pretty basic for a unit of this type. It includes a on and off switch for the engine, a receptacle, 120 volt. This is a 120 volt only generator. Circuit breaker is here for the receptacle, and it also has a DC output here that for the charging the cables with a circuit breaker in front of it. I added gasoline to the fuel tank and added the recommended 10W30 to the crankcase here, 12 ounces of 10W30, and the gasoline was that I used was just 87 octane E10, the typical pump gas that you buy anywhere, and started the unit, choked it, started the unit, and found that the unit was very temperamental as far as it started fairly quickly, but was difficult to get the choke opened up on the unit. And went back to the manual, and it said to allow the unit to run 5 minutes before adding load. So I allowed the unit to run with the choke partially open for about 5 minutes, and then was able to open the unit completely and get the engine to run fairly smoothly with the choke open. I looked around my shop, and I found that I had a 1400 watt rated heat gun, and that seemed like the perfect load for my new 1400 watt generator. Give me a chance to try it out at full capacity. To monitor it, I inserted a kilowatt unit, and sometimes I even have a 3-prong output plug on it, so if I need to go with multiple devices, I can do that. And then I plug the heat gun into the kilowatt unit. I've added a combination runtime induction tachometer, which has been added on here. So that's something that's been added to the unit. It doesn't come with that device on it. All right, now the kilowatt unit, for those of you who may not be familiar with it, is a really neat electronic device which will give you on this digital display here the such things as the output voltage, any device that's plugged into its output. This orange three-pronged, three-outlet device is plugged in here. So if I plug my heat gun into this, then it will give me the wattage, the amperage, the frequency that the engine is running at, and so forth. So very excitedly I pulled the trigger and brought it on to about the minimum heat. It's a two heat settings, and the kilowatt indicated that I was drawing about 707 watts, and the voltage was 123.6. I thought, oh, everything really looks good. So then I went ahead and pulled to the high heat, which should bring the unit up to the full 1400 watts. And the engine did carry the load. It continued to run, but the voltage, output voltage, as recorded by this device, was down to 101 volts, and the frequency was at 55.7 hertz. Hertz is another word for cycles per second, if you're not familiar with that term, which means the engine couldn't get the unit, the alternator up to speed. It needs to run 3600 to produce 60 cycle power, and in short, the generator just could not deliver 1400 watts to my 1400 watt load that I was putting on it. Alright, I began to check to see what could possibly be the problem. This is the choke. This is in a full choked position, and this is a full open. And I did double check to make sure the choke was fully open. As I mentioned earlier, I'd allowed the unit to run for about 5 minutes to get the engine warmed up, and it just seemed as though there was just nothing that could be done in order to make the unit run properly at full load. I will mention here that this hose and valve is something that also I've added. It's kind of common. I've been putting a T in my fuel line. This is the original fuel line up here. And the idea is that when this unit is put into storage, I can easily drain the fuel tank so that I don't have fuel go bad after a number of months. In other words, this is not a part of the original unit. It's something that's been added. As I continued my checking of the unit, I came across something kind of interesting. First of all, I don't know if you'll be able to see this in the camera, but here is the outlet, the AC outlet, and here is the circuit breaker for that outlet. That circuit breaker is labeled underneath it 8.5 amps. Well, 8.5 times 120 is not 1400 watts, which is claimed to be the rating of this unit. It's about a little over 1,000. And I went further, took the control panel off where I could get in behind and see the circuit breaker itself, and the circuit breaker is labeled as 8 amps, 8.0 amps, not 8.5, which again would suggest that whoever was engineering this was expecting a maximum load of 8 amps, which is what, 960. 8 times 120 is 960 watts. So all the evidence would suggest that this unit is not designed to operate at 1400 watts as was shown in the literature and on the box that it came in. And I certainly could not get the unit to run at 1400 watts. I did drop the load down to about 1250 watts, again using the heat gun at low setting and adding a 500 watt quartz floodlight to it, and it couldn't carry that load either. The throttle on the engine under either of those loads was fully open, nothing left. In other words, it couldn't be opened any further to get more engine speed out of it. So I don't know for a fact that this is a 3.5 horsepower engine as is claimed, both on the box and as labeled here on the end. I looked up the technical information on a Honda GX120 engine. I found the horsepower rating for this particular engine at 3.2 horsepower with a displacement of 122 cc's. If we divide this displacement by the horsepower, we have a 38.1 cc per horsepower. Now the Sportsman indicates a displacement of 94 cc, If we divide that displacement by 38.1, we would predict that perhaps the Sportsman engine has a rating of about 2.5 horsepower. However, the published rating is 3.5 horsepower. Now obviously, you can't necessarily compare the output of one manufacturer's engine against another solely based on displacement, but we know that the engines are both rated at 3600 RPM under identical situation. So there is some question in my mind as to why Honda needs 122 cc's to produce 3.2 horsepower. Perhaps the Sportsman engine may be a bit overrated. The next phase of my testing involved the fuel consumption estimates. I was interested in a small unit that could run for a lot of hours while sipping as little fuel as possible. And as you see, I have here the basic technique that I used for testing it was to shut off the main fuel valve here, run the engine till the carburetor went dry. Then I have another valve here, which we've talked about previously, and this is connected to a hose to this auxiliary tank. Now the procedure used was to take a measuring cup, put 4 ounces of gasoline in this auxiliary tank, and then start the engine and time how long it would take to burn those 4 ounces. In doing that, also I was changing the load from a no load condition up to 960 watts. At no load, the number that I came up with was 0.099 gallons per hour, and at 522 watts the number was 0.144 gallons per hour, and at 960 watts the fuel consumption was 0.208 gallons per hour. So the manufacturer had basically said that this unit would run 9 hours on a tank full of gas, which is 1.2 gallons, which is 0.133 gallons per hour if I've done the math properly. So the consumption figures were perhaps a bit higher, but very close to the manufacturer's stated capacity rating on gas consumption. I was pleased about that. Running this generator, I noticed an operating characteristic that I really didn't care for. I found that under part load, let's say 500 watts or less, sometimes when the load was suddenly applied, the engine would surge for perhaps 30 seconds or so. It usually settled down on its own, but it was not a desirable feature of a generator to be surging. So I took a look at the carburetor, and what you see in my hand is the original manufacturer's carburetor that I've taken off of the unit. And usually, to correct the problem, there is a pilot jet approximately where my pencil is pointing. As you may be able to see, there's just a brass plug in that opening. No way to adjust it. So I decided so that I could return the unit to its original condition, I decided just to buy another carburetor for it. And the replacement carburetor has a screw at this location so that the air fuel mix this is called the pilot jet. I'm not sure that I mentioned that, but this would be for adjusting on low load conditions the fuel air mixture. And when I put that on the unit, I was pleased that first of all I could start the unit, and then within seconds I could take it off a choke. I didn't have to wait 5 minutes for it to warm up. And also the surging that I mentioned earlier, when the unit was under partial load, that surging completely went away. So this was a nice addition. I'm sure that the manufacturer put this carburetor in with this plug in it so that it meets perhaps certain EPA standards or something. And probably my generator doesn't meet those now, but it runs a whole lot better. I did try again after changing out the carburetor to put a 1400 watt load, also a 1250 watt load again, kind of repeating the experiment load wise, and I didn't find any improvement in the ability of this unit to carry the load. So while the engine runs better and does not surge nearly so much, the capability of handling a 1400 watt load was never achieved. We've moved the camera for a close-up of the replacement carburetor shown on the engine, and hopefully you can see my pencil pointing here. This is the idle screw. Of course, generators never idle, so it's pretty much a useless screw. But right here is the pilot jet with the needle valve that can be adjusted in and out to adjust for the partial loading and to reduce the surging issue. So anyway, this was a very nice correction for this. I might be able to remove the brass plug from the original carburetor, and I might find an adjustment screw inside there, but like I said, I wanted to preserve the original equipment as much as possible. It's possible I might tear the carburetor up in the process, so anyway, my approach was to replace the carburetor rather than trying to modify the original. Okay. I'm standing outside now taking sound readings, and as you can probably tell, I'm using a cell phone here as a instrument, just an app on my telephone. Today it's rather windy and blustery out, about 45 degrees, and it's actually swinging between 80 and 90 decibels. My first test was done on a much calmer day, and the wind does seem to have some impact on my readings here, but basically I've moved away from the generator 23 feet in 4 directions and took readings, and the average reading I was getting was 81 decibels. The manufacturer claims a 68 decibel rating for this unit, so I'm afraid it's a bit exaggerated in my opinion. The one item that I found kind of questionable was the warranty for this product. On their warranty card, they have a statement, and I read it as follows right off, as it is on the card. And it states, "Factory second, discounted or second-hand products purchased from third-party retailers or Amazon or eBay are not covered by this warranty." I find that a bit disappointing, and I assume that if you have purchased this product through Amazon or eBay, as I did, there's absolutely no warranty for the product. Okay, we're looking at the screen on my computer. It's a screen from the Better Business Bureau. It appears that all warranty issues concerning this generator are dealt with by the Buffalo Corporation, or sometimes called Buffalo Tools. They're located in O'Fallon, Missouri, and they're the importers of tools and other equipment, have been in business since 1965. What you may have noticed, if you look closely at the screenshot, is that they have an F rating by the Better Business Bureau. It seems this is primarily the result of customer complaints relative to complaints about their service or warranty issues, primarily with their generators. They do sell a lot of other things, but most of what I've read as far as the complaints that seem to have dealt with generator warranty issues. I guess in defense of Buffalo, I'd like to mention that I contacted the company by email and asked if it was possible to obtain a service manual or data sheet that could be downloaded, which would provide engine torque information, bolt information, valve lash requirements for this generator. I did receive a quick response from the company, and they did provide me the valve clearance or valve lash, the ignition coil gap, and spark plug gap information, but no mention was made of the engine torque requirements. So it's possible they just don't have that information, but I would not necessarily give up on this company, because they did at least respond to my request for information. In summary, let me say that on an internet search, I found that this unit sold for slightly under $200 to as well over $400. Seems unusually wide for the product. I guess it's buyer beware when you purchase this product. I noticed here was a generator had a 2,000 watt surge rating. I did not attempt to to test for surge rating because I couldn't find any kind of a technical definition of surge rating. I'm tempted to think that surge rating is really a fictitious, useless number for these small generators. Third item in my summary, I've noticed that the generator was not able to produce a rated output of 1400 watts. The circuit breaker on the receptacle is rated at 8 amps, which suggests that the continuous output should be no more than about 960 watts. So to have a rating of 1400 watts on this unit just doesn't seem to make sense. Item 4, the horsepower rating of the engine may be exaggerated. This I didn't prove, but it's possible it's exaggerated. The noise level of the engine, and I think in this video you've heard it run, is pretty significant. It's claimed to be 68, and the test data suggested perhaps 80, 85 decibel. Apparently the purchaser of this generator, in this case myself, does not have any kind of a warranty because I bought it from Amazon, through Amazon. So this is something for the prospective buyer to be conscious of. The general construction of the generator appears good. The crankshaft is supported by ball bearings. The unit is equipped with an oil shutdown switch and comes with a toolkit. It also includes a DC output for charging batteries. Its small size and weight are attractive features. Even with fuel in it, it is about 57 or 58 pounds. In general, the unit seems that has most of the features of its bigger, more expensive sisters at a really low price. It's difficult to determine the quality of the piston rings and so forth, so engine life is really hard to predict. You'll just have to run and see what kind of life I get out of it. If one ignores the manufacturer's apparent exaggeration claims concerning the unit output noise rating, I would be tempted to give this unit a positive rating. I've enjoyed tinkering with it, and I think I'm going to find it useful. Anyway, that's my summary of what I think of this unit. Thank you.